Alright, so 2-1, as I said, is going to talk about patterns and inductive reasoning. And so let's look at your review. So you have to tell whether the statement's a conjecture and explain your reasoning. All apples are sweet. Conjecture or no? Your definition of a conjecture would be what? Perhaps you should look up your notes in chapter 1. Okay, so very good. See, one of you knew it. So your conjecture is an opinion or an educated guess based upon your experience. So is this an opinion? Yeah. So yes, it's an opinion. What about the sun sets in the west? Is that an opinion? No. It's a fact, isn't it? So therefore it's not a conjecture when it's absolute fact. There's no disputing the sun sets in the west. So it's not a conjecture, it's a fact. And so the answer to this one is no. So that's really a pretty good question regarding conjectures. Then we've got a new vocab word which you need to add to your flashcards. And it is reason. And here's your definition of reason. Reason is an explanation. I really prefer this main idea here to what we use a reason for in geometry. It's all logical arguments use reasons to support your conclusion. And then I really don't care about number 3. Let's look at number 4. Write R if the estimate is reasonable or U if it is unreasonable. So I'm going to give you about a minute to think about those. And these are estimates, so they don't have to be exact. What do you think about number 4? Reasonable or unreasonable? How many of you think it's reasonable, Rachel? How many of you think it's unreasonable? So the unreasonable is habit. Brenna, why do you think it's unreasonable?
Because it doesn't add up to that.
What does it add up to?
It doesn't add up to 49.
So we've got, if I were to estimate this, 32 is close to 30, right? 11 is close to 10, so what's 30 plus 10? 40. And 6 is kind of in the middle, 46. Isn't 60 way off of that? Now I just estimated it. She's right. It adds up to 49. So that's why it's way off. Unreasonable. Your educated guess, your estimate is not very accurate. 15% tip. A lot of you go out to dinner with your parents. Is there any kind of guessing on tips? Any arguments with your parents on tips? How to calculate it? Have they taught you how to calculate a tip? Okay. Yes, some of you. How many of you parents have taught you how to calculate a tip? How do your parents taught you how to calculate it?
But I use actually
You multiply by what? You just multiply it out. Eric, how about you? Same? Who else does it differently? There's your actual estimate right there, because I don't have to get out my calculator and multiply by 0.15, although you all have your cell phones on you all the time, right? So you can whip out that calculator and put it in there. But if we want to estimate based upon, I usually estimate by 10%. I typically will give a 20% tip because it's nicer to go to waitress. And that's also easier to calculate. If I have a bill that's $36, 10%, just as Chris said, you essentially cover up the last digit and turn that into dollars and cents. Well, if I cover the last digit, don't you see $3? So that's 10%. So 10% is approximately equal to $3. And if you really want to be accurate, it's $3.60. Because if I put my decimal, move my decimal over one place to the left, it's $3.60. Then 5% more would give me 15%, wouldn't it? So I just estimate about half of it. Half of $3 is $1.50, and half of 60 cents is 30 cents. So I get $1.80. And then I personally would round this up to $2. Plus 3 is 5, let's make it an even 6. So somewhere if you're giving them $5 or $6, what was their answer? What was their answer? $6. So that's a reasonable answer. All right, so let's turn the page. So we're going to look at patterns. There's some strategies that you need to use to find a pattern. So we're going to go through problem 1 and use some strategies. And then I'm going to give you some additional patterns that we'll try to squeeze in on this page. So what are the next two terms in the sequence? As you're looking at 45, 40, 35, 30, it's pretty simple to figure out what the pattern is. Is the overall sequence of numbers increasing or decreasing? Are they increasing or decreasing? You're decreasing. How do you decrease? Through operations. That would be what? Subtraction or division. Right? Subtraction or division decrease numbers, so that means that multiplication and addition increase numbers. So I know that probably subtraction or division is occurring here. So the first thing I'll do is try to look at, is there a common difference? And you learned that last year in algebra. So the common difference here would be -5, right? Common difference here, -5. Common difference here, -5. So that right there gives you the pattern because it's the same every time, right? As you go through here, do the numbers increase or decrease? We already said that they decrease. Does the amount of change vary or remain constant? Everybody. Constant. Which operation helps you form the next term? We already determined that it's subtraction or division, so we only have that option. Which number helps you form the next term? 5 or 15? The 5, because we're subtracting by 5. And so now find the next two terms in the sequence. What are they? 25 and then 20. So that one wasn't too tough. We're going to do problem 2 before I give you the other pattern. So let's look at problem 2. It's not a number pattern, it's a letter pattern. And these ones are harder because you're not quite sure where the letters are coming from. So they've got, what conjecture can you make about the 21st term in this pattern? So we've got an R, a W, a B, an R, a W, a B. So it looks like there is some sort of pattern occurring, correct? That pattern is split right there. So then they've shown you just what I showed you, that there's two different cycles being shown. And then they're going to assign a number to that term, to that letter. And so the first R is term 1, the first W is term 2, so B is term 3, the next R is 4, 5, and 6. And there's a reason for this. There are how many letters in the pattern before it starts repeating? Just sit up. Sit up. All it, because I'm going to take a nap. And it's not nap time. You just woke up. You might want to go back to sleep though. We don't want that to happen. Alright, so there's 3 letters in the pattern, so it's important that when you do see a pattern occurring, how many items are in that pattern before it starts to repeat. And they may not give you the whole repeat. So they might have stopped the pattern here at RW. Our assumption would be that the next one is probably B. So they might not give you a full repeat. R is the first term, the 4th term, and what else? It'll be the 7th also, right? And so forth. So it's 1st, 4th, 7th. W is the 2nd, the 5th, right? And then what's the next one going to be? Because if the 4th, or if R was the 7th, then W would have to be the 8th, right? And then look at these. From 1 to 4 is how many numbers? 3. 4 to 7? 3. 2 to 5? 3. 5 to 8? 3. You also start to see a pattern forming here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then underline the correct words to complete the sentence. The 21st term is 1 more than a multiple of 3, 2 more than a multiple of 3, or exactly a multiple of 3. So the 21st term would be a multiple of 3, 2 more than a multiple of 3, or 1 more than a multiple of 3. Just look at the number 21. It's a multiple of 3, isn't it? And typically what I'll do, if I'm trying to find the 21st term, I'll look at the number of items in the sequence in that repeat pattern. In this case it's 3. And I'll take 21 and divide it by 3. Since it goes in there 7 even times, don't we know that the 21st term is the last term in that pattern? Because there's no remainders. So I've gone 1, 2, 3. That's an even sequence. 4, 5, 6 is 6, 1 is an even sequence. So every multiple of 3 is the ending. So these are all multiples of 3 here, is the ending term in that sequence. So the 21st term is going to be a what? It's going to be a B. And so now make that conjecture. The 21st term of the sequence is B. Now what if they had asked for the 44th term? How are you going to deal with the 44th term? How many items are in the sequence? 3. So I would take 44, divide it by 3 terms, and let's use 3rd grade math where we had a remainder. So 3 goes into 4 once, with 1 left over. 3 goes into 14 twice, not twice. I can actually do math. I really can. 3 times 4 is 12. So that gives me a remainder of what? 2. So that means that the ending 1, the second remainder, is the letter that we're looking for. Since I have a remainder of 2, 1, 2, wouldn't the 44th term be a W? Right? And we could count it and double check it. But we'll be right. Alright, so if it's not a nice, perfect multiple of whatever the pattern sequence is, that's how you deal with that. So questions on that? You ready to try some patterns? Some of these are easy, some are hard. Alright, so I want you to find the pattern. We're going to turn it on the side. Find the pattern. For each sequence. Then find the next 2 terms. So I want you to determine if it's a numbered pattern, is it increasing, decreasing, am I using addition, multiplication versus subtraction, division. If it's a letter pattern, you can kind of use the information that's here. Although one of the letter patterns I give you is a toughie, I'll be shocked if any of you get it. So I've got 5, 10, 20, 40. That's the first one. So when you think you know what the pattern is, write down the next 2 terms in sequence. And you need to be able to describe what's happening with the pattern. You can't just know what the next 2 terms are, you need to be able to explain to somebody what's going on with that pattern. So talk to people around you, see if they agree. And there could be more than one way to describe a pattern. somebody talk to Mariah. She's very, very lonely over there. It's like, oh, too much attention. All right, so Ashley, what'd you get? Listen. You just discuss it. How can we work with it? Did you get nervous? The reason why I want you to discuss it is if you didn't understand it originally, you're discussing it with somebody, so now you're an expert on it now, right? Because there's going to be a pattern that you didn't see, that somebody else saw, and there'll be a pattern that you saw, but somebody else didn't see. Because some of these patterns are spatial reasoning, some of them are numeric logic reasoning, and so they're different sides of the brain. So it is an increasing pattern, right? And so if it's an increasing pattern, we're looking for either a common difference, that would imply addition, or if there's not a common difference, it's probably some sort of multiplication. So the common difference here was 5, here was 10, and here was 20. So it's not addition per se. There's not a pattern in the addition itself anyway. So then you might try, okay, 10 divided by 5 is 2, so we could multiply by 2, got 10. Multiply by 2, got 20. Multiply by 2, got 40. That's working every time, right? So what are your next two terms in sequence? 80 and 160. Good. All right, so then B. Let's try 1, negative 1, 2, negative 2, 3, dot, dot, dot. Now this is a sequence that's easy to find the sequence, the next two terms, but how do you describe it? And this is not a sequence that is increasing or decreasing, it's doing both. So it's an odd one. So talk amongst each other, see if you can come up with a reasonable explanation of the sequence. Tell somebody else, boys, and see if they agree with you, since you wholeheartedly agree with each other. Okay, so let's just start with everybody. What's the next term in the sequence? Negative 3, and the next one? 4. So Brody, how did you guys describe that? You were very excited about your description. You were not? You both look equally excited.
I give him the high five.
Write me check? Yeah. So Brody, explain your pattern.
Okay. He plus minus 2 plus 3 minus 4 plus 5 minus 6.
Very nice. Isn't there a pattern to the addition and subtraction going on here? So the next one would be, he's right, from here to here would be minus 6, and the next one from here to here would be plus 7. So it's 2, 3, 4, 5, 6, 7, alternating addition and subtraction. Would this be an easy one for me to ask you what's the 40th term? No. Definitely not. So probably I wouldn't do that to you. All right, C. This is my favorite. O, T, T, F, F, S, S, E, dot, dot, dot. If you thought there was a pattern, the first and last letters, throw that out. And then, what's the rhyme or reason to the letters chosen? There has to be a rhyme or reason to the letters chosen. It is mathematically oriented, that's all I'll tell you. It does relate to a math concept. Discuss it amongst yourselves. The letters is harder because it's a different brain. It's your different brain of thinking. But it is mathematically related. Some of you don't even know where to start, do you? You're like, what? You have an idea, Brenna. What's your idea?
It goes 1, 2, 3, 4, 5, 6, 7, 8, 9.
She just got it immediately. It's the first letter of the counting number set. So O for 1, T for 2, T for 3, 4, 5, 6, 7. And now you see it, right? It's like, oh, I would never have thought of that. I totally wouldn't have thought of that. But, exactly. But the next time you come across a letter sequence, won't that come to mind the next time? Oh, it could be a number set. So if I did odd numbers in the counting set, then we would take out every other letter, right? So, I mean, it could be something like that. So write that down because you might forget it. First letter of each counting number. The set of counting numbers starts with 1, 2, 3, 4, in case you forgot. And so 8, 9 would be N, and 10 would be T. All right, let's redeem yourself. Last one. Oh, let's fit it in. We'll fit it in over here. How about 1, 2, 6, 24, 120, dot, dot, dot. So use your tools of finding patterns. Start with, is it increasing or decreasing? Start with the operations that do that. Does it work for everyone?
No.
Okay. So then go back to the drawing board.
No.
All right, Sam, what do you think? Got any ideas? Yes. What's your ideas? So it is an increasing pattern, right? So from here to here, I mean, if you tried addition, it was +1, and then here +4. Here, it was quite a big difference, right? So there's no pattern in the addition. So then if you go to multiplication, well, 1 times 2 is 2. 2 times 3 is 6. 6 times 4, oh, it's looking good. And then this must be times 5. So if you check it, it is 120. So then the next one would be 120 times 6, which is 720. And then it would be this times 7, which is a lot, 54. Okay? So my suggestion when you're doing tonight's homework, don't immediately jump to the answers. Hold off on the answers till all possible, because otherwise you're just going to look, and you won't learn. All right, so let's turn the page. So we should be looking at problem 3. I find this an interesting problem. I like it a lot. So what conjecture can you make about the sum of the first 30 odd numbers? So, number of terms, so we've got term number 1, 2, 3, 4, 5, and it says the first 30 odd numbers. So the first number adds up to itself, 1. The second number is 1 plus 3. 3 is your second number. Are you listening? So that adds up to 4. They made a little hint here that 1 is 1 times 1. 4 is 2 times 2. Okay. And then for the third term we have 1 plus 3 from before plus 5. If you add those up, what do we get? 9. And 9 is what times what? So far, the sum has been, what kind of numbers are these? What kind of a number is 1, 4, and 9? They're very special. Does not start with a C. Perfect squares. Aren't they perfect squares so far? Let's see if the pattern continues. So for the fourth term, we've got 1 plus 3 plus 5 plus 7. So the shortcut is just to take 9 and add 7 to it. Is 16 a perfect square? Yep, and what multiplies give you 16? 4 times 4. You should be seeing a pattern here along with something else in this chart. And then for the fifth term, we've got 1 plus 3 plus 5 plus 7 plus 9. So what's 16 plus 9? 25. And that is 5 times 5. So what is your conjecture? The sum of the first 30 odd numbers is going to be what? You have to make the conjecture based upon the chart and what you see. What's the connection about the chart? So the sum of the first 30 odd numbers is what? It will be a perfect square. The sum of the first 30 will be a perfect square. Well, we should be able to tell what it is right now. First number, 1 times 1. Second number, 2 times 2. Third number, 3 times 3. Fourth number, 4 times 4. Fifth number, 5 times 5. 30 numbers is what? 30 times 30. I'm trying to think of what they wanted me to put in there. Oh, that's a dot. See, I can't read it. It's too tiny. It's 30 times 30 or 900. Right? You can multiply by power, or not, that's not really a power of 10, but 3 times 3 is 9 and tack on 2 zeros. Done. No need for a calculator. So what would be the sum of the first 50 odd numbers? 50 times 50 would be a 25 and 2 zeros, so 2,000. So piece of cake now. Now you can ask your parents, quiz me on any first, whatever odd numbers. I can tell you what it is right now. They're going to go, you're so smart. Because they won't know it, because they won't know the pattern yet. All right, so let's make some predictions based upon graphs. So there are certain graphs that shows a pattern, shows a trend. And we use patterning to forecast with particular graphs. As you can see, this graph, over time, and these are your months, and so N represents what? November. Just checking. So we got November, December, January, February, March, April, May, right? And so as the months go by, what's happening to the number of backpacks sold? It's decreasing. So it's a decreasing pattern. It's important to realize that. And so you need to decide if the following conjectures are true or false. The graph shows a pattern of points. Are the points showing an overall pattern? True or false? True, because it's showing a decreasing pattern. Now, it may not be a perfect line, but that's okay. Overall, it's got a general pattern of decreasing over time. Each month, the number of backpacks sold increases. True or false? False. The change in sales varies from month to month, so you need to estimate this change. Is the change in sales exactly the same? So like from November to December, we went from 11,000 to just above 10,500. So that's not quite, just shy of a $500 difference, right? Or 500 backpack difference. And then from December to January, we have just above 10,000 and just above 10,500. That might actually be a 500 backpack difference, right? So they're not exactly the same, are they? But are they close to the same number? Yeah. And then here, that's a bigger jump, isn't it? This is over 500. You can just see visually. And then here, that's about, it's a little over 500, but really close to 500. And this looks like it's about 500. So some are different, some are the same. So the change in sales do vary from month to month. That's true. So you need to estimate this change. That's true. I want you to do 21 and 22 on your own. Let's see how you do. All right, so discuss your answers with those around you. I hear true or false. Are we agreed? Okay. So if sales change by about 500 each month, which give or take they do, you can subtract 500 from April to get May's sales. Seems somewhat reasonable, right? It may or may not be on the ball because, as you can see, from January to February, there was a big jump. Why do you think over time backpack sales have dropped? It's a school year. At the end of the school year, there's not a whole lot of need to buy a backpack because the parents are going, you can make do with the one that's broken. I'm sure some of you have dealt with that, right? Lots of sales in November because, heaven forbid, you should get a backpack for Christmas or whatever, right? Yay, thanks, I got a backpack. Even worse would be underwear, right? Yay, thanks for underwear. If sales change by about 500 each month, you can add 500 to May's sales to get June's sales. Well, that would be increasing. And that might be okay if it were June to, or if it were July to August. Why? School starting. So that actually might be okay if you were talking about July to August. But we're talking May to June. Summer starting. You're not going to buy a backpack, most likely. Not going to be a huge demand. All right, so question 23. Now make a conjecture about backpack sales in June. About blank backpacks will be sold in June. So let's estimate. So we've got April. April is about what? April sales. April is about equal to 8,500, right? How many months are there from April to June? Or, I'm sorry, we're going from June. So how many months from April to June? 2. So each month it's been decreasing by about how much? 500. So for 2 months, we've got to count for moths. 2 months. I'm having issues. That's going to be approximately 1,000. And we're going to subtract that, aren't we? It's decreasing. So our guess would be about 7,500. Good with that? All right, so then on this is the last one, right? Oh, no, we have one more in the back. Problem 5. Let's talk about counterexamples. And this is going to be tough for some of you because you're used to proving things are true. A counterexample, although you are a teenager, so you ought to be really good at arguing about things. And that's what really a counterexample is all about. Is you are trying to prove something is false. It's much easier to prove that something is true than it is to prove that it's false. So, for instance, if an angle is acute, then it is 60 degrees. Is that a true statement? Can you come up with a counterexample? Counterexample means something to prove that statement false. If an angle is acute, then it is 60 degrees. How would you prove me false? 35-degree angle. Isn't that also acute? That's a counterexample to my statement. Now, if I had said, if an angle is acute, then it is less than 90 degrees, we'd be okay, right? It'd be hard to find a counterexample against that. So that's what I'm talking about. So let's look at this one. And you might want to write yourself a little note here. Counterexample, prove a statement false. Because what you're going to do is try to prove the statement's true, and you're looking for the one situation, and it might only be one situation that causes a statement to be false. So this question says, or this conjecture says, if a flower is red, then it is a rose. That's a true statement. Well, a rose can be red, right? That could be a true statement. Sometimes. Question 24 says, circle the flowers below that can, or that are, or can be red. Rose, right? A bluebell. Do you even know what a bluebell is? No. But the conjecture is that it is blue. So it's probably not red if it's called a bluebell. A carnation, can you have a red carnation? Yeah. Might be more pink than red, but yeah. Geranium, you know what those are, right? No? They're red. They can be red. Yeah, they can be red. They smell real bad. The leaves, nasty. Tulip. Mom may have had some tulips around Easter. Not tulips, but tulips. It's my mom joke here today. All right, so tulips can be red. They're usually yellow or purple, but oftentimes they're red or a little orangey red, but definitely tulips can be red. Now, what's the problem with this question? What were some of you having trouble with? You don't know what the flowers are. If you don't have any experience with these types of flowers, how are you supposed to answer this question? So there is an issue with experience. All right, so is every flower you named a rose? No. So write a word to complete the counterexample. A blank is a red flower, but it is not a rose. So you're naming the fact that it's a flower. And by the way, we always want to keep, this part of the statement right here is called your given. You must maintain the truth of that given. So when you write a counterexample, you have to maintain the truth of the given. So you can't choose something that is, you can't choose something that's not a flower, and you can't choose something that couldn't be red. You have to maintain the truth of that statement. So I have to choose a flower that is red, number one, and then for the counterexample, it can't be rose. So there's your opposite. This part right here is your conclusion. So the if part of a statement is generally your given, must be true. Your then part is your conclusion, or what follows. So what could I put there? Carnation, or geranium, or tulip. Now, technically, there's a whole slew of ones you could put there, but those are the only choices I gave you. Okay, so I've got one other thing for you, but you're not going to have a lot of room, so get out a piece of paper. You're going to create some counterexamples for the following. So while you're getting out paper, think about this. rained last night, then the ground is wet. Can you find a counterexample to that? The sprinklers could have caused the ground to be wet. We live in the state of Arizona. If it rained last night, is necessarily the ground wet this morning? So sometimes your experience in a different place may affect your answers to counterexamples. So we'll talk more about that in a moment. If you give a mouse a cookie, then you will want a glass of milk. That entire book is all about if-then statements and conjectures. It's a fabulous book. Love that book. All right, so find a counterexample. So, first statement. If the name of a month starts with the letter J, it is a summer month. Write a counterexample. So you have to maintain the truth of the given, but prove the conclusion's false. So could I say December is a winter month? What's wrong with that? It doesn't start with J. So is there a month that starts with J that is not a summer month? January. So your answer would be January starts with J. So you're maintaining the truth of the given by stating that January starts with J, but it is a, what kind of month? Winter. It's hard to tell in Arizona, but it is a winter month. All other places it would be a spring month. Right? All right. B. You can connect, and here's where your geometry knowledge and postulate knowledge comes into play. You can connect any 3 points to form a triangle. So if I were to turn this into an if-then statement, you would cut it at the subject of the sentence, which would be points. So if you can connect any 3 points, comma, then you can form a triangle. True or false statement. If it's a false statement, you got to be able to come up with a counterexample. Is there any way that you connect 3 points and not form a triangle? There is a way. Daniel, what's your way? You're nodding, yeah. Who knows what way there is? Josie? Ah. There's nothing that says that the points can't all be on the same line, right? So, oftentimes a picture can suffice as a counterexample. So if the 3 points, bless you, are, what's this called? Collinear. They will not form a triangle. So I definitely would draw a picture. If it's a geometry-related counterexample, draw a picture. And I have one more. So C. When you multiply a number by 2, the product is greater than the original number. So once you think about, this one's harder to think about it because it draws you into, oh yeah, that's true. There's situation or shuns where this is not true. So think for a moment on your own and then discuss it with those around you, see if they agree, see if they've thought about that. So who has two numbers that you multiplied together? One of them has to be 2, where the product is not greater than the original number. What's a negative number? Okay, so you can take 2. So if 2 times, pick any negative number. Oh, thank you. Such boys. So we chose a number we could easily multiply here. So 2 times negative 3 is equal to negative 6. So if 2 times negative 3 is equal to negative 6, then it says the product is greater than the original number. So the product is negative 6. It is not greater than the original number, negative 3. Negative 6 is actually less than negative 3 on the number line. So that is correct. What about 0? Could you have used 0? 0 would have been another option, right? So multiplied by a negative or by 0. All right. So my suggestion would be that you take this paper and staple it to the notes that I gave you.